Hello, everybody. My name is Edward. Is the zero-divisor graphs of certain matrices. So in this research, we studied the zero-divisor graph of a ring that has two zero divisors as vertices, and those two vertices are connected, or we build an edge between them if and only if their product equals 0. So here we used just basic graph theory properties as well as set theory principles to guide us along the research. So we will begin with the definition. So to define the tridiagonal matrix that we researched. So we let P equal a prime number and TP, the set of all tridiagonal matrices, be the set of matrices as defined here. So here, as you can see, we have 5 entries, and they could vary between 0 and 1 in modulo P equals 2. And ZP is the set of all zero divisors of TP. Z of TP is the set of all zero divisors of TP. We ended up counting all the zero divisors. We had to derive a formula for that. So we let P equal a prime number, and the cardinality of TP equal is P to the 5th. Z of TP has 27 zero divisors. Because we applied P equals 2 here into the formula, and we derived that. So now we have 27 zero divisors. Here we do a visual representation of that, those 27 zero matrices, divisor matrices. Next, we partition TP into 7 parts. And we did this because we focus mainly on, specifically on the main diagonal, where if one of them is 0, then the matrix will produce a zero divisor. So here in S7, we include a condition because we want to make sure that the matrix in question is not 0 itself, because that's part of the condition of this project, of this research. Here is the underlying graph that we developed from those partitioned parts, matrices. We describe properties of this graph, mainly the degree sequences, the in degree sequence, the out degree sequence. We talked about its Eulerian properties, such as providing an Eulerian circuit. We also proved that it's Eulerian because the even degrees, the degrees are even here. So we also proved that it's semi-Hamiltonian because it only has a Hamiltonian path, but not a Hamiltonian cycle. Here we follow the path, and we will touch on every vertices exactly once. For the Eulerian, we have to touch every edge exactly once, and arrive at the same vertices. So we continued on the entire zero divisor graph. We show that it has 27 vertices, and it has 158 edges. 27 vertices from our 27 zero divisors. And the edges are 158 edges between those, the connections between those matrices. We show that some of the matrices are in fact isomorphic to one another, as described here. S1 is isomorphic to S7, and so on. Here we list the 27 zero divisors. And finally, we show a couple of samples of their bipartite graphs between them. So we show that, for example, here S4, S7 provides this graph, and that is isomorphic to S1, S7 because they have the same structure. Finally, we conclude with providing, so we provided a complete structure of the class graph, the directed and undirected of this, and the zero divisor graph for the tridiagonal matrices. And our focus now, our ambitions now are to proceed to P equals 3, where we will try to describe the properties of that. Thank you very much, everybody. Thank you, Dr. Lee. Thank you, Dr. Gint and LSAMP for this opportunity, and have a great day.